Hello students, this question is taken from test series 1 EE from the subject power electronics from the topic applications of power electronics. A 220 volts 960 rpm 80 amps separately excited DC motor has an armature resistance of 0.06 ohm, which is nothing but a separately excited DC motor having the voltage 220 volts at speed 960 rpm having armature current as 80 amps and armature resistance of 0.06 ohm. VDC is 220 volt, speed 960, armature current 80 amps and armature resistance 0.06 ohm, and it is driving from a step down chopper whose input voltage is 220 volts. This drive is used to drive a constant load torque, which is nothing but the step down chopper input voltage and the separately excited DC motor input voltage is 220 volt, so that it produces the constant torque load. We have to find the duty ratio of chopper, so that load is running at 680 rpm. We have to find that duty ratio at load is running at 680 rpm. The given question, given condition, torque is constant. Torque is constant. So the formula for torque is directly proportional to phi Ia, which is nothing but phi is equal to constant for separate excited motor. For separately excited DC motor, the value of flux is constant. So torque is directly proportional to the armature current. So T1 by T2 is equal to Ia1 by Ia2, which is nothing but the value of torque is constant. So the value of T1 by T2 is 1. So we can write armature current Ia1 is equal to the armature current Ia2. So the value of back EMF directly proportional to the speed, that is N. So EB1 by EB2 is equal to N1 by N2. From this we can find EB2, that is back EMF 2. EB2 is equal to EB1 into N2 by N1. I had to find the value of back EMF 1. We can find, that is EB1 is equal to, for motor, V1 minus Ia1 RA, which is nothing but input voltage, that is VDC is 220 volts minus Ia1 armature current 80 amps into armature resistance 0.06, will get 215.2 volts, that is back EMF 1. Can substitute the value of back EMF 1 in this, can get EB2 as 250.2 into 680 by 960, will get 152.43. After calculating EB2, to calculate the voltage V2, that is output voltage, that is the formula for EB2 is equal to V2, same thing like this, V2 minus Ia2 RA, where Ia1 and Ia2 is same. Ia1 is equal to Ia2. So can calculate the value of V2, that is V2 is equal to EB2, we can 152.43 plus Ia2 is 80 amps into RA, which is nothing but 0.06 armature resistance. After calculating this, we will get the value of V2, that is 157.23. So I have to find the duty ratio at load is running at 680 rpm. So here value of this is, the load is running at 680 rpm, that is 157.23. Then we can calculate the value of duty ratio, that is delta is equal to the load at 680 rpm is 157.23 by the load at running at 960 rpm, we can calculate as 220 voltage is 220 volts. After calculating this, we can get the value of duty ratio as 0.7147, which is nothing but 0.7147. In this session, we have studied about how to calculate the duty ratio of chopper for a separately excited DC motor. Thank you.